Welcome back, everyone. Ready for another deep dive?
Always.
Awesome. Today we're going deep into machine learning. Some cutting-edge research, actually, fresh from arxcorridor.org, January 6th, 2025.
Really nice.
Yeah. For those who don't know, Arcus is it's like where scientists share their findings before they even make it into those like official journals.
So we're getting a sneak peek.
Exactly, a sneak peek. And you, our amazing listeners, you sent in a ton of articles on some really cool new developments. So, let's dive in and see what we can dig up.
Sounds good. From what I'm seeing, there's some really fascinating themes emerging,
Oh.
like algorithms that can actually pinpoint signals even when they're buried in tons of noise.
Wow.
And even the idea of actually teaching machines to apply what they've learned in one situation to a totally different problem.
That's interesting.
We've even got some glimpses into the future of applications,
Wait.
like personalized medicine, self-driving cars, even understanding historical maps. We're even talking generating 3D models just from videos.
Okay, now you've got me hooked. Let's start with this one. Signal recovery. Using a spiked mixture model. The idea of pulling out meaningful signals from noisy data, it's like finding a needle in a haystack, isn't it?
It really is. And, traditional methods often struggle with that.
Yeah.
But this spiked mixture model, it offers a whole new approach.
Yeah.
Instead of just treating all data the same, it zeroes in on these specific spikes that really jump out from all that background noise.
So it's not just about how much data you have, but the right data.
Exactly. You'd think more data is always better, but this model shows how targeted analysis, focusing on the right beta, can actually lead to much better accuracy.
That's pretty counterintuitive, and they're actually applying this to analyzing brain tissue and segmenting images.
Right. Imagine you're trying to identify specific molecules in a complex brain tissue sample. This model helps pinpoint those targets, even when they're present in super tiny amounts.
So like finding a specific grain of sand on a beach.
Exactly. And in computer vision, it helps define, define the boundaries between different objects in a really blurry or cluttered image. It's kind of like how our brains automatically separate, a dog from the background when you see it in a park.
Oh, I see. Okay. So then what about this transfer name and Pearson algorithm for outlier detection? Now that title sounds like it sounds straight out of a sci-fi movie.
It does, doesn't it?
Yeah.
But the concept itself is actually pretty fascinating. Imagine you've got a model trained to spot, like fraudulent financial transactions.
Okay.
And now you want to use that same model to detect anomalies in, let's say, network traffic data. The patterns are totally different.
Right.
But the idea of something's not right here, that's transferable. That's what this research is all about.
So it's not just about recognizing specific patterns, but about learning a general concept, like a sense of unusual behavior.
Exactly.
And then being able to apply that to completely new situations.
Precisely. And this actually ties into another article, Gradual Domain Adaptation, where they're actually teaching models to bridge that gap between very different types of data. Instead of just abruptly switching from one domain to another, they're using these intermediate steps. It's kind of like teaching someone a new language by starting with those similar words, those cognates, and then gradually introducing more complex grammar.
So you're like easing the AI into a new language. That's pretty clever.
Yeah.
Could this gradual learning, could it be applied to other areas of AI, like, helping them adapt to new environments or new situations?
Absolutely. That's a key area of research,
Hmm.
especially, when you think about AI actually operating in the real world where things are always changing.
Yeah.
Yeah, for sure. Okay, let's shift gears a little bit. We've talked about finding those signals and transferring knowledge, but what about making AI less likely to freak out when it encounters something it doesn't expect?
Yeah.
This paper here on SAFER, Sharpness-Aware Layer Selective Fine-Tuning for Enhanced Robustness in Vision Transformers, really caught my eye. It sounds like they're, like giving AI a chill pill.
Yeah, a chill pill with some pretty sophisticated algorithms for sure.
Right.
This SAFER technique, what it does is it addresses a problem called adversarial overfitting. Think of it like this. You train a dog to recognize only your car.
Okay.
It gets so specialized that it might not even recognize any other car. So what this technique does is it helps the AI model generalize better, makes it less sensitive to those small irrelevant variations in the input data.
So instead of fixating on those tiny little details, it's learning to see the bigger picture, the underlying concept of car, regardless of its color, make, or model.
Now, that's what I call a valuable life lesson. Not just for AI, but for all of us, right? But speaking of real-world applications, let's move on to some of the amazing ways this technology is actually being used to solve problems in the real world. His stack of research is like a peek into the future, from revolutionizing healthcare to changing how we drive and even how we understand history itself.
It really is. And, I think you'll be surprised by some of the things they're doing with machine learning these days. For example, did you know they're actually using it to reconstruct images from CT scans? They're personalizing facial expression recognition and even helping self-driving cars navigate those complex city streets.
Hold on, they can actually personalize facial expression recognition. That sounds both amazing and a little creepy at the same time.
It is. It's not just about recognizing those basic emotions anymore. It's about understanding individual expressions in a more personalized way. And on the self-driving car front, well, imagine a world where cars can not only recognize traffic signals, but they can also understand those subtle cues from pedestrians and other drivers.
That's mind-blowing. So
Right.
it's about making AI more sensitive to the nuances of human behavior and
Yes.
not just following those rigid rules, right?
Exactly. And this brings us to one of those fascinating and it maybe unexpected applications, using machine learning to actually digitize historical maps.
Oh, wow.
There's a paper here on semantic segmentation for historical maps. And get this, the technique can learn from just a single map and then apply that knowledge to other maps from the same era.
Hold on. It can learn from just one map. That's like cracking a code and then unlocking a whole library of knowledge. What kind of information can they even pull from these maps?
All sorts of things, everything from, geographical features and population density to even clues about economic activity. It's like bringing history to life. It gives a whole new way to understand the past. And speaking of bringing things to life, another area that's just exploding is video analysis and generation.
So are we talking about like enhancing video resolution, lifting 2D videos into 3D, and even creating custom videos using specific photos? Is this what they're using to make all those deep fakes I keep hearing about?
Well, the technology could be used for that. It's important to remember that deepfakes are just one application. The real power here lies in the ability um, to create realistic and personalized video content for all sorts of things, from entertainment to education and even scientific visualization.
Okay, so give me an example.
Imagine like generating a 3D model of a dinosaur just from a video clip,
Yeah.
or creating a personalized training simulation for a surgeon.
Wow, this is truly the stuff of science fiction, but it's happening right now. It seems like every area we've touched on so far is just pushing the boundaries of what's possible. But before we get lost in all the possibilities, we need to talk about the big one, the elephant in the room. Large language models. LLMs?
Ah, yes,
They're everywhere these days.
they are.
But there's also a lot of debate about, their impact and the potential risks, right?
Absolutely. LLMs, they're incredibly powerful tools, but like any powerful tool, they need to be used responsibly. And that's what a lot of these papers are actually trying to address.
So they're looking at ways to enhance LLM safety
Right.
through concept-based alignment,
Yes.
improve their ability to generalize knowledge to new situations,
Exactly.
and even tackle issues like hallucination, where those LLMs generate content that sounds plausible, but it's actually factually incorrect.
It's a big challenge, but there's some truly innovative research happening in this area.
Oh, like what?
Well, one paper I found particularly interesting. It focuses on a data set called reading between the lines. It's specifically designed to help LLMs understand the difficulty of different texts.
That's fascinating.
It is. And this could have huge implications for accessibility and inclusion,
Right.
making sure that, everyone can access information regardless of their reading abilities.
That's a really important point. We often get caught up in all the technical stuff, but making AI accessible and beneficial for everyone, that's crucial.
I agree. And as we delve deeper into this research, we'll see even more examples of how scientists are not just tackling the technical challenges of AI,
Right.
but also the ethical and societal implications.
This is what I love about these deep dives. It's not just about learning the what, it's also about the why and the so what. It's about understanding the bigger picture and how all of this is going to impact our lives.
I couldn't agree more. Let's jump back into those research papers, shall we? Remember all that talk about making AI more reliable? We've got a great example here in a paper called Enhancing Large Vision Model in Street Scene Semantic Understanding through Leveraging Posterior Optimization Trajectory.
Wow, okay. That's a mouthful. What does that even mean? It sounds like something straight out of a physics textbook.
It does sound a bit intimidating, I'll admit. But the idea itself is actually pretty straightforward. Think about like a self-driving car navigating a busy street. To stay safe, it needs to really understand what's around it. Pedestrians, other cars, traffic lights, you name it. So this research, it's all about making those eyes of the self-driving car, the large vision models, even better at interpreting what they see.
So like giving the car a sharper vision, a better understanding of the world around it.
Exactly. And that posterior optimization trajectory part, well, that refers to a clever trick they use to actually speed up the learning process. It's kind of like, imagine training a dog. You wouldn't start from scratch every single time, right?
Right.
You'd use what you already know about their personality and their past training. That's kind of what's happening here. They're leveraging past knowledge to actually guide future training.
So it's learning from its own experience, making it a faster learner.
Precisely.
That's fascinating. Okay, now I want to switch gears a bit to something a little more on the creative side. There's this paper here called Ingredients, Blending Custom Photos with Video Diffusion Transformers.
Okay, now that one definitely has me intrigued. What's the story there?
This research, it's all about making AI-generated videos more personalized. Imagine taking photos of yourself, your friends, your pet even,
Okay.
and then like creating a video where you're all, say, dancing on the moon.
Wait, dancing on the moon, that sounds like something out of a dream. Is that even possible? That's the idea. Giving people the power to create those unique and imaginative video content using their own photos. And the video diffusion transformers, well, they're the magic behind it all. These are those powerful deep learning models, the ones known for creating those hyper-realistic visuals.
Okay, that is seriously cool. We've gone from analyzing brain tissue to dancing on the moon. It seems like the possibilities with AI are, well, they're endless.
They really are.
But let's not forget about the importance of making AI more robust, less likely to make mistakes, especially when we're talking about like self-driving cars or even medical diagnoses.
You're absolutely right. Reliability is it's paramount, especially in those fields. There's one paper here I think you'll find interesting. It's called A Minimal Subset Approach for Efficient and Scalable Loop Closure. It tackles a problem called loop closure detection, in robotics and navigation.
Okay, I'll be honest, that one sounds a bit over my head. Can you break it down for me?
Sure. Imagine like a robot exploring a maze. As it moves around, it's creating this map in its memory. Loop closure is when the robot recognizes that it's actually returned to a place it's been before. And this helps it correct any errors in its map. It's kind of like, if you were hiking in the woods and suddenly realized you'd walked in a circle. You'd use that knowledge to reorient yourself.
Ah, that makes sense. So it's all about helping the robot understand its environment better and avoid getting lost.
Exactly. And that minimal subset part, well, that means they're finding ways to do this more efficiently using less computational power. And that's really essential when you're dealing with robots that need to make those split-second decisions in real time.
Okay, that's really clever. It seems like a lot of this research is about finding that sweet spot between powerful AI and practical real-world constraints.
You've hit the nail on the head. It's a constant balancing act. Now, let's shift gears again, back to something a little closer to home. Facial expression recognition. I think you'll be pretty intrigued by this paper on uncertainty-aware label refinement on hypergraphs for personalized federated facial expression recognition.
Okay, I'm definitely going to need you to unpack that one for me. Starting with federated learning. What is that exactly?
So federated learning, it's a way of training AI models without actually collecting all the data in one central place. Imagine like your phone learning from your facial expressions,
Okay.
but without actually sending that data to some company's server. That's the whole idea behind federated learning, keeping data private while still allowing AI to learn from it.
So it's like learning from the crowds, but without actually gathering everyone in a single room?
Precisely.
That sounds perfect for these privacy-conscious times. But how does that uncertainty-aware label refinement thing, how does that fit in?
Well, even for us humans, facial expressions can sometimes be a bit ambiguous.
Right.
A slight smile could mean happiness, or it could just be politeness. It could even be discomfort. So this research actually takes that uncertainty into account, making the AI model more accurate and more robust, even when it's dealing with those really subtle expressions.
That's amazing. So they're teaching AI to understand not just the expression itself, but also the context and the potential for ambiguity.
Exactly. It's all about nuance.
That's pretty advanced.
It is, and this actually leads us to another interesting challenge: deploying AI on devices that have limited resources, like smartphones or even those tiny little sensors. There's a paper here. It's called "Dedicated Inference Engine and Binary Weight Neural Networks for Lightweight Instance Segmentation" that tackles this head-on.
Okay, before we go any further, break that down for me. What is instance segmentation?
So instance segmentation, it's a computer vision task where you don't just identify objects in an image, but you actually outline their exact boundaries. Think of it like coloring within the lines, but for AI, it's a pretty computationally demanding task, usually requiring some pretty powerful hardware.
So how do they make that work on something like a smartphone, which has, limited processing power?
Well, they've got two clever tricks up their sleeve. First, they're using something called binary weight neural networks. Instead of using a whole range of values, these networks use only -1 and +1, and that dramatically reduces the computational burden. It's kind of like simplifying the AI's brain to make it more compact and efficient.
So like a streamlined, lightweight version of a traditional AI.
Precisely. And the second trick, that's a dedicated inference engine. And that's a specialized piece of hardware that's specifically optimized for running these binary weight networks. Think of it like a custom designed chip that's perfectly suited to this specific type of AI.
Huh. Okay, so they're not just changing the software, but they're actually creating new hardware to make AI more efficient. That's pretty impressive.
It is. And this highlights a growing trend in AI, finding these creative ways to make powerful algorithms work within those real-world constraints.
And speaking of powerful algorithms, we can't wrap up this part without circling back to those large language models, the LLMs. Earlier, we talked about, some of the ethical concerns and the work being done to kind of mitigate those risks. But there's also a lot of research focused on making LLMs even more capable and versatile.
You're absolutely right. And one paper that really caught my eye is it's semantic segmentation for sequential historical maps by learning from only one map. Remember how we talked about using AI to digitize those historical maps?
Yes, that was one of the most fascinating applications we've discussed.
Well, this research actually takes it a step further. Not only can it learn from a single labeled map, but it can also exploit those temporal relationships between maps from different time periods. It's like piecing together a historical puzzle, using each piece to reveal more of the bigger picture.
That's incredible. It's like the AI is becoming a historian, making connections and uncovering hidden insights from the past.
Exactly. And this is just one example of how LMs are being used to tackle those really complex challenges in these innovative ways.
Okay, my brain is officially overflowing with information. We've covered so much ground in this deep dive, from robots navigating mazes to AI historians uncovering secrets of the past. But I'm sure there's still more to explore, right?
You're right. We have a few more fascinating papers to discuss in part 3, each highlighting a different facet of this amazing field.
All right, hit me with it. What else is cooking in the world of machine learning?
Well, how about we talk drones?
Drones. Okay, I'm listening.
There's this paper, it's called UAVDTR, Efficient End-to-End Object Detection for Unmanned Aerial Vehicle Imagery.
Catchy title.
Yeah, well, academics. But what it focuses on is it's all about helping drones actually identify objects from the air.
That sounds like it has some pretty big real-world applications.
Oh, absolutely. Think about it. Search and rescue operations, environmental monitoring, inspecting infrastructure like bridges and power lines. This research could make all those tasks so much safer, faster, more efficient
Right.
by giving drones a much sharper set of eyes, so to speak.
So instead of just capturing video, they'll be able to actually understand what they're seeing.
Exactly.
Okay, that is impressive. Now, this one sounds like it's straight out of a Photoshop tutorial. Towards hard and soft shadow removal via dual branch separation network and vision transformer. Shadows. Really?
I know, it might seem a little mundane, but actually removing shadows from images,
Mm-hmm.
it's a really tough challenge for computers. And this research, it's proposing this new method using, a kind of two-pronged approach.
Oh.
They recognize that hard shadows and soft shadows, they actually require different techniques to remove.
So it's like having two specialized AI experts. One for those like sharp, defined shadows, and another one for the softer, more subtle one.
You got it. And by combining their expertise, they can remove shadows much more effectively, leading to, much better quality images in the end.
Makes sense.
It's really all about understanding the nuances of light and how it interacts with the world around us.
I'm constantly amazed by how specialized these AI models are
Me
becoming.
too.
It's like each one is, I don't know, like a master craftsman, just honing their skills in one specific area.
It really is remarkable. It's a real testament to the power of deep learning. Being able to capture those those subtle patterns in relationships, even in something as, well, seemingly simple as a shadow.
Yeah, yeah. Okay, before we wrap up this deep dive, there's one more paper I have to ask you about. It's this one, Virgo, a preliminary exploration on reproducing O1 like MLLM. It delves into the world of multimodal large language models. Multimodal. Okay, that sounds intriguing.
It is intriguing. So while those traditional large language models, they just focus on text,
Right.
these multimodal LLMs, they're designed to actually understand multiple types of data, like
Hmm.
text, images, audio, even video. It's like giving them all their senses, allowing them to learn from a much richer, more complete picture of the world around them.
So instead of just reading a book, it's like they can watch the movie, listen to the soundtrack, and even smell the popcorn.
That's a great analogy. And this Virgo model, well, it's an attempt to actually replicate the capabilities of this really powerful multimodal LLM called O1, which is known for its ability to reason across those different data types. It's a real step towards AI that can truly understand the world in a way that's, well, it's closer to how we humans do it.
Wow. We've come a long way from those simple algorithms to AI that can almost think like us. It's both exciting and, well, a little daunting at the same time.
I agree, and it really underscores the importance of those ethical considerations and responsible development as we move forward, as we continue to, push those boundaries of AI. We need to make sure that we're creating a future that we can all be proud of.
Well said. Listener, we've covered an incredible amount of ground in this deep dive into machine learning, but it's really just a glimpse into this vast and ever-evolving world. What stood out to you? What sparked your curiosity? What questions are still swirling around in your mind? The journey of discovery, it doesn't end here. Keep exploring, keep questioning, and keep diving deep into this amazing world of AI.